Okay, hello everyone. My name is Franklin. Welcome to Operating Systems. I hope that you have all had. I mean, I don't know where a lot of you are coming from. I hope you had a good work term. I hope that you had a good class term. I hope that you've had a good whatever. I hope that you got a little bit of a break in between classes, or in between your work term and today. I hope that you're not just coming from work term on Friday to here on Monday. I gotta be honest, I wasn't expecting Kyle to open the class like that. I wasn't expecting him to start the class like that. So I'm kind of I don't know, just a little bit off kilter here. But that's totally fine. That's totally fine. Today, what I want us to do is to talk a little bit about the course, and I want to get right into things. By the end of today's lecture, what I want you to be able to do is describe some of the basic responsibilities and organization of an operating system. So we're going to do a little bit of me telling you about what an operating system is, how it's organized, and I'm going to ask you some questions about that. I want you to be able to write code that uses system calls to create and manage processes. So I'm going to demonstrate this to you. This is described in our textbook, but I'm going to demonstrate this to you today. And some secondary goals here related to write code that uses system calls to create and manage processes is that I want you to be able to write, compile, and debug basic C programs. How long ago was it that you took Comp 2160? You can show number of years. 2, 3, 1, 3, 2, 1. Lots of ones. Is that a 0 or is that a 3? 3, 3, 3. Okay. It's been a while. It has been a while for many of you since you've written a C program. It's been a while for many of you since you've compiled a C program, and it's been a while for many of you since you have used a source level debugger. If you have ever used a source level debugger, it's the Visual Studio Code debugger for C. I gotta be honest. I have to be really honest. I don't know how to use it. I don't know how it works. I am kind of an old person, and I just prefer to do command line debugging. So that's what I'm going to show you in class today. People have asked me before, how do you set up the VS Code debugger for C? And they open up a JSON file, and I'm immediately just mystified. Why do I need to edit this JSON file to do debugging in a C program? And then I give up, and I tell them as much. I don't know what to do. I'm sorry. So we're going to do that today. And what I want to introduce us with, though, is kind of learning a little bit about the course. This is the part where I was going to ask Kyle to say hello to you. And like I said, I wasn't exactly expecting him to just open the course like that. So I'll pretend to be Kyle. Hi, everyone. I'm Kyle. Kyle is going to be your TA for the term. I'm going to tell you about labs in a second, a little bit more about labs in a second. But labs in this course, for the purposes of what we're doing, you can kind of treat them as Kyle's office hours. So this is your opportunity to go and talk to an expert in this course. Kyle is someone that has done this course before. He has done very well in this course. He knows the course material. This is an opportunity for you to go take advantage of that on top of the office hours that I have. The lab sections themselves, it doesn't matter which lab section you're attending. It doesn't matter which lab section you're registered for, just show up to a lab section. So in Aurora, there's 4 different lab sections listed. Just show up to a lab section and talk to Kyle. You know, if the room is full, which it shouldn't be, but if the room is full, be respectful if this isn't actually your lab section, but I'm not anticipating that the lab is going to be full every single time. Lab slots are scheduled every week. There aren't lab exercises every week, but Kyle will be in the lab every week. So even on weeks where there isn't a lab, Kyle's going to be in there. These are his office hours. So this is your opportunity to go and say hello to him. This picture on the side here, yeah, I was trying to figure out what picture to put here. I didn't have a photo of Kyle, and I didn't want to ask Kyle for a photo of himself. So I decided to try using ChatGPT in combination with DALL-E to generate an image. And so the prompt that I gave to ChatGPT was, can you make me a prompt for DALL-E 2 that would give me a good representation of a teaching assistant for a university course in operating systems? And before today, I've actually never seen Kyle. I've never seen him before. And this seems like it's a reasonable representation. Like, he's got a beard. This guy that's generated has a beard. The lab is maybe not exactly what it's going to look like. I mean, the labs on the 4th floor are not that bright. But I don't know, maybe that represents a student. And I've got no idea what is supposed to be on the screen. It's really tiny, but it kind of looks like if you squint, it could be an editor or something. I don't know. I'm digressing. Let's take a look at our course ROAS. So here's our course webpage. Everything that you need for this course is going to be on this course webpage. I'm going to pop open the content section, and then I'm going to go to the course resources and then the course schedule and ROAS here. In this document is everything that you need to know about how this course is structured, and all of the course material that you need is going to be linked to from this document. It's kind of a long document, but it's got everything that you need in it. I am your instructor for this course. My name is Franklin, and you can address me as Franklin. My preferred pronouns are he and him. If you're going to send me an email, that's my email address. If you want to come visit me during class time, that's when our lectures are. If you want to come and visit me during office hours, that's when my office hours are. I realized this morning looking at this that this is happening at the same time as Comp 3350. How many of you are in Comp 3350? I am going to change my office hours to try and make sure that they're not happening at the same time as Comp 3350 as software engineering. That's on my to-do list, so I'll let you know what the updated times are. But for the record, I also generally have an open door policy. If my door is open, just like knock and say hello and come talk to me. I am usually on campus and around between like 9 and 3, so feel free to come drop by. Regardless of when my office hours are, if the times that I do schedule still don't work for you, you've got a part-time job or something, whatever, like you can't be on campus that time, send me an email and we can try to arrange an appointment for me to be guaranteed to be in the office when you need to come and talk to me. This is a course about operating systems. This is a course that's going to be about operating systems. This course is a course where we're going to be building on what you've learned in Comp 2280 and building on what you learned in Comp 2160. In Comp 2280, one of the learning outcomes that you had, so for computer engineers, Comp 2280, that's like our initial architecture and assembly language programming course. In Comp 2280, one of the learning outcomes that you had from that was to have the ability to do things like just to describe the difference between program mode and system mode, or user mode and system mode. That's one of the things that we're going to be building on this very week. In Comp 2160, while it's not a C programming course, you learn to program in C, and then that's kind of what we're building on from that in this course. This course is effectively an applied data structures and algorithms course. That's effectively what operating systems is. We're going to be spending a lot of time using different words to describe things that are data structures that represent concepts in an operating system, data structures that represent things in an operating system that are also coincidentally linked lists. Hey, we're never going to get away from linked lists. We're always going to see linked lists. We're going to build on linked lists, and we're actually going to start talking about queues eventually, but it's still just a linked list underneath. It's a linked list in disguise. Ultimately, what we're talking about is the idea of a piece of software. This is the stuff that we're looking at is the code that we write is going to be C. The operating system that we're going to be working with is also written in C. It's just programs going all the way down to the bottom. An operating system, in summary, is a piece of software that manages resources, where the resources that you've got are things like your CPU and memory and hard drive and input and output devices like keyboards and stuff. By the end of this course, what you should be able to do is write and analyze concurrent programs. So we're going to be using threads. We're going to be using concurrency, coarse-grained concurrency in the form of processes. You should be able to describe, implement, and analyze scheduling algorithms and policies. This is where we're getting into queues. You should be able to describe and analyze strategies for managing memory, physical and virtual. This is related to Comp 3370. If you do take that, this is talking about the idea of virtual memory. And this is kind of related to the idea of processes and what a process can see about its state in the world, which is an operating system. And I want you to be able to describe, implement, and analyze data structures and algorithms used in file systems. This is kind of like the ultimate thing that we're looking at in this course, is you're going to be writing code that will be able to read a file system from a file. That's my favorite. That is absolutely my favorite part of the course. I really love that. Being able to take this blob of bits and be able to get stuff out of it, be able to get files out of it, and be able to think about how an operating system is actually representing the data that we have on our file system. We have this idea of a file folder structure that looks like this. What is the operating system actually doing underneath? What is it using? What data structures is it using to represent all of that? In this course, I am recording these lectures. I'm actually streaming them directly to YouTube right now. The YouTube stream is not, I don't have chat and stuff enabled on that. It's just meant to be a stream and a recording for the course. So if you're participating remotely on YouTube, it's really just going to be watching. That's what we've got for this. The lab meetings, like I said, these are basically going to be Kyle's office hours. There's no attendance required at the labs. It's really recommended that you go to the labs if you need the help with the labs, if you need help with assignments, if you need help with course material. This is your opportunity to go and talk to Kyle. Like I said, he's going to be there every day that there is a lab offered or a lab scheduled in Aurora, so please take advantage of that. The textbook that we're using for this course is called Operating Systems, 3 Easy Pieces. This is a really excellent textbook. I've been using this for a while, and I think it's great. I think it is a really excellent textbook. It's really importantly, it is a free textbook. All of this is available on this page. If you really like the textbook, you can buy a hard copy of it, or you can buy a PDF that has all of the pages all in one giant PDF. But all of the chapters and resources here are just available for you to read on this web page. However, I have also linked to the chapters that you need to read for our course directly in the schedule itself. So you can find links directly to the PDFs for this, this textbook in the schedule that we'll see in a little bit. When you're communicating with me, my policy is that I want you to send me an email from your U of M email address. When I get emails from Gmail or something, it's an honest mistake. I get it. I usually just reply and politely ask you to respond using your U of M email address. It's not really a big deal. I just prefer to have everything under the control of the U of M. Questions that you have about the labs, assignments, and other course materials, you can send those to Kyle either in his office hours or on the course forum. You can contact them for anything, Kyle. You can contact Kyle for anything that you need. You can also contact me for anything that you need. Any questions that you have about labs and assignments, I would really strongly prefer that you ask those on the forum itself or to me or Kyle verbally, as opposed to sending me a private email. My rationale for that, for the forum part, is that if you have a question, probably 5 other people have the same question. And so if I can just answer it one time on the forum, that's going to be better for everybody. The course forum is linked to at the top of the Learn page. It is this discussions link, so you can find it right at the top of this page. It's available and open for you right now. If you've got questions about your test that is like, I have questions about how I've been assessed on this test, then please email me privately. Something that's specific to you, please just send me an email as soon as you can. I scan for academic integrity cases in this course. So all submissions that are submitted as part of assessment for this course, I scan against everyone in this room, and I also scan against everybody in previous offerings of this course. So please be aware of that. What you can expect from me, I am going to return assessments to you on assignments before the next assignment is due. We've got 3 graders in this course. This is more than we normally have. And the reason I have more graders than I normally have is because I want to get things back to you as soon as possible. My goal here, and I didn't write this down, but my goal is to get them back to you within a week of submission. So not like the day before the next one is due, but to give you enough time to make changes to what you're doing. For the term test, I promise to give you feedback before the final exam on the term test. I plan to use a variety of teaching strategies in the classroom, so it's not always just going to be me up here shouting at you. I know this is a getting started class, but that's what it's going to look like today for the first part. Later, I'm going to do things like invite you to code along with me. So if you have a machine in front of you, you have an internet connection, you can connect to Aviary or just use your own machine. We'll do that today. There's other things that I'll do, like quizzes on the screen, or I'll be asking you to do some more active learning strategies throughout the term. If you have course material that you can suggest to me, sometimes students have good stuff that they've seen elsewhere. If you find something that you feel is better described to you somewhere else, please let me know. I would be more than happy to share that with other people in the course. I am going to reply to forum posts and emails within 3 business days. I don't check my email over the weekend. This is my job. This is my job. I need to balance my life and my job. I've got 2 kids. Not that I need to excuse myself, but I've got 2 kids and I love to spend time with them. And I'd rather spend time with them than you. Sorry, but I've got to balance my work and life. So I don't generally respond to emails over the weekend. I don't generally respond to emails that I receive after 3 p.m. until the next business day. So please just be aware of that when it comes time to things like submitting assignments and questions and stuff like that. Recording lectures, almost everything that I do in the classroom, I will put up on Learn. There's not much reason for you to record stuff. If you feel like you need an audio recording that's separate from the mic that's attached to me right now, let me know, but I don't think that should be a problem. This is a 6-week course, so the revision deadline and VW deadlines are fairly tight. The revision deadline is on Thursday of this week. It's on Thursday of this week, and that's for add and drop. I'm really hoping that from the email I sent you, you've had some time to think about the course already, and so I'm hoping that there's not a significant amount of churn in the next few days, but the revision period is there. The VW deadline is on June 1st of this year. The masking policy at the U of M has been dropped. I think we're all aware of that. That's fine, it is what it is. If you are sick, I would strongly prefer that you don't come to class still. Being respectful of me, being respectful of the people that you have around you. If you come to class and you want a mask and you don't have one, just come and ask me. I have lots. They were just giving them out like candy all over the place here. I've got lots. If you need one, if you want one, come and ask me. I will be streaming these lectures on YouTube. I will post the link to the lecture in advance of the class time, but I've also created a playlist. So, and I'll be putting all the lectures on that playlist. So if you can't come to class because you're sick or whatever, just find everything up there. The policy for extensions and exemptions for things is that you have to submit this self-declaration form for brief and temporary absences if you're sick and unable to attend a term test, or if you're sick and unable to submit an assignment or a lab. You have to submit one of these forms to me, and you can do that by email. This is a 6-week course. This is a 6-week course. I'm deeply sorry that this is a 6-week course. I didn't schedule it. I'm just kind of along for the ride here. If you're unable to attend the term test and you submit me one of these forms, you are exempt from the term test, and the weight of it will be moved to the final exam. If you're unable to submit a lab or an assignment on time, submit one of these self-declaration forms to me, and the weight of that will be moved to the final exam. There are no late submissions. I'm not going to be rescheduling term tests. If you missed the term test and you want to see it for practice purposes and you are sick, send me an email and I will send something back to you so that you can see what that exam looks like. If I am sick, I don't plan to come to class. If I'm sick, I don't plan to come to class. I will either find somebody to stand in for me. I will get Rob to put his best Franklin impression on and come and do the class for me, or I will alternatively stream the course on YouTube or on Zoom or something. I will make something available for you to do that. If I can't do that and Rob is not available, I may cancel the class, but I will make sure to give you advance notice, and I will send information about that to your U of M emails. Okay. So, are there any questions about anything so far? Yes? You mean like with your fingers and stuff, or what?
Like, we have commenter variables, talking about the code standard.
Yeah. There's no like rigid formal standard that you must adhere to. Realizing that I forgot to put the programming standards up. So that's also on my to-do list. There's no rigid programming standards like you have to use Javadoc style comments on your functions and stuff, but you will be assessed on code quality. And part of code quality is adhering to things like providing comments that describe meaningfully what your code does. That doesn't mean like comment every single line and say, if this, then that, and like assign value to whatever. It's more like, you know, help the person that's reading your code be able to follow what your logic is, what your internal mind state is. I'm not sure if that answers your question enough. Okay, good. Okay. So sorry, I want to put this down on my list of things to do here. So I need to change office hours. And I need to put up the programming standards. Okay. All right, so the schedule part of this document is a week-by-week breakdown of what we are going to be doing, the readings that you're required to do from the textbook, and all of the supplementary material that's available to you throughout the course. Each week, I am going to be putting a link directly to one of these sections in the content part of the course. So I'm going to post my lecture notes, and I'll also post a link directly to this just to save you a little bit of time instead of having to scan through this entire document to find the week that we're currently on right now. Every week has the same kind of structure as week 0 here. I state formally the learning outcomes that you are going to be demonstrating, or you should be able to demonstrate to me by the end of the week, or the end of the part of the week that we're looking at. And then I've got a set of readings that you are required to complete. These are going to be part of the course. So some of the course material is going to be in the textbook. Some of the course material is going to be in the classroom. A lot of what we're going to be doing in the classroom is a lot more practical demonstration of stuff, and the textbook is going to be like the theory stuff that's related to that. I will constantly be referring to the textbook, and the general expectation is that you will read this material before you come to class for that week. Week 1 is a better representation of what what 1 week will look like. So there's going to be some deliverables that you're expected to do. The first lab is due this Friday at 4:30 p.m. And then a subset of subtopics that have some set of learning outcomes. The readings here, this is a link directly to the PDF of the chapter in the textbook. This is a set of reading notes that I have prepared for myself as the audience. So like when I'm reading these textbooks, I am also like writing along with them. And the purpose of me sharing this with you is to give you a sense of what I'm thinking about as I'm reading the textbook, to give you a sense of what I'm thinking about as I'm reading the textbook. This is not required. It's not required for you to read these reading notes. This is just for your benefit, to give you some additional viewpoints of what the authors are talking about. That's supplementary material. Some of the chapters I have prepared videos for, summarizing the textbook. The reading notes are not a summary of the textbook. They're just my internal monologue. This is what I'm thinking about as I'm reading it. This is questions that I have about the material. This is me sometimes answering those questions, but sometimes I don't even know the answer to the question. This is just me like thinking out loud with my fingers. The YouTube videos, it's kind of like you can watch the YouTube video or you can read the textbook chapter. It's your choice, but they are effectively considered the same thing to me in terms of content. So like don't read 3 chapters and then on top of that watch a 45-minute long YouTube video. Don't waste your time that way. In terms of the YouTube videos, pick one or the other. You don't have to do both. This is a special week. This week is a special week in that one of the things that we're reading is not from the textbook itself, the one that we have stated as required for this course. The other half of what we're doing this week is something called interprocess communication, so how processes talk to each other when they're running. And this comes from a different textbook. The 3 Easy Pieces book doesn't cover IPC at all. I don't know why. I'm not really sure why the authors made this decision, but they just don't cover it at all. So instead, I'm giving you a copy of chapter 15 of this other book called The Advanced Programming in the Unix Environment. This is also a pretty good book. It's more of an operating system usage textbook than anything, but is not free. So I got the library to scan chapter 15 for you. So it's there. There's also a bunch of manual pages that I've linked to. You don't have to read the manual pages, but what I will say about the manual pages is that they have code examples in them. I'm going to show you this stuff anyway in class, but the manual pages tell you how to use the functions and system calls that you're going to need to use for this week's material. Again, I'll do that too, but they are there for your reference so you know what manual pages you need to take a look at. I'm going to skip past the rest of this. And like I said, these are going to be linked directly to in the content for each week of the course. So you'll have a chance to see those. In terms of assessment, I've scaled back this course a little bit, just in that we only have 6 weeks instead of 12 weeks. I normally have 4 labs and 4 assignments, but that kind of had an awkward cadence of like, I'm not sure when to put the deadlines for things. So I've scaled it back to 3 assignments and 3 labs. And the idea here is that every week you're submitting something, and every other week it's the opposite thing. So this week you're doing lab 1, next week is assignment 1. The week after that is lab 2, the week after that is assignment 2. The week after that is lab 3, the week after that is assignment 3. There's a term test that's scheduled in there that is kind of midway through the course. I'm going to go back really quickly up to the top here to the table of contents. The term test is scheduled the week of lab 2, so this is halfway through the course. And I'm going to go down to week 3 here. and it is scheduled on May 25th. It's just happening in class. I'll tell you more about that when we get to that point, but it will just be an in-person, on-paper term test. There's also, I guess since we're here anyway, there's also a special class that's scheduled on the Friday of that week. That class is just canceled. We're not going to have that class. Monday is a holiday, and we shift things over, but I'm just canceling the Friday class. I think we'll all need a shorter week and a shorter week. We all need a shorter week at that point. Okay, back to assessment. The other thing that there is going to be is a final exam that's scheduled by the registrar's office. We generally have this policy in this course for the final exam. When we've had final exams is that you must pass the final to pass the course. That also applies here. The final letter grades are based on percentages, and they're based on kind of the normal distribution of things that you would expect to see. So A+ is 90%, A is 80 to 90, and kind of so on down the path there. The extension and late submission policy, like I said, the deadlines are firm. There's no extensions. If you are unable to submit an assignment due to illness or whatever, please just let me know as soon as you can, and the weight of that will be moved to the final exam. All right, okay. How are we all doing? Yeah, okay. We're doing okay. We're doing okay. It's going to be a lot. It's going to be a lot. It's going to be a lot. I don't really need to mince words about it. It's going to be a lot. But my job is to help you get through this. That is my job. I don't want to impede your progress. I don't want to get in your way. My job is to help you get through this stuff. If at any point you need to talk to me about something, come and talk to me. Please come and talk to me. And I'm not saying that just because I get lonely in my office. I do get lonely in my office, but please come and talk to me. I want to help make sure that you can succeed in this course. I don't want me to be the reason why you're not able to succeed in this course. Please make sure you come and talk to me about anything, and I will be more than happy to talk to you. Okay. Let's start by asking a question. What even is an operating system? And I want you to tell me this at the beginning. What even is an operating system? Take a couple minutes on your device to tell me what you think an operating system is, what it's comprised of, what makes an operating system tick. Pieces of code that run other code. Yeah, absolutely. This is a program. It's a piece of software who has the responsibility of helping other software run efficiently and effectively. The connection between the hardware and the software that manages resources. Yes, I really like that. An operating system feels like it's the piece of software that's sitting almost just directly on top of the CPU. And it's sitting directly on top of the hard drive, and it's managing everything for you. A super program that will handle all the programs. Yeah, I think that's kind of related to the first point here. Software that manages hardware resources. Yes, very generally, the project manager for a computer, essentially. I like that, the project manager for a computer. Making sure that a process has a certain budget and that the programs that are running don't exceed that budget, or they get things done on time. Pieces of code that manage resources. Yeah, software that will manage the code and hardware run for other programs. Software that manages the hardware. I'm going to say that this is a good point. This is software that manages the hardware. It's not like necessarily managing the hardware in terms of directing the hardware about what it should do, but rather giving access to the hardware. It's giving access to other software to be able to make use of the hardware, as opposed to like being a director of how the hardware should do what it's supposed to do. A resource manager, everything is a file. I like that this one is showing up here. Everything is a file. We'll see this a little bit later, but on Linux and Unix operating systems, basically everything does look like a file. So like you've got a keyboard on your screen. you've got a keyboard on your screen. Yeah, you've got a keyboard on your screen. You've got a keyboard on your screen. You have a keyboard in front of you. You could read from a file that represents the keyboard to get keyboard input, as an example. Kind of a weird thing to think about. You can write to a file that represents the screen to draw stuff on the screen. Not directly anymore, but it's there. This idea is there. It's a program that manages hardware, a system that operates. OK, that's the very literal definition of it. Thank you. I don't know. Fair enough. I don't know. Here is a diagram that I really like that I did not make myself. I stole this from Wikipedia. I really like this diagram, though, because I think it does a good job of telling us what an operating system is approximately and how things fit together from our perspective. I'm actually going to open up the wiki page, and I'm going to open up this thing so that it's a little bit bigger so that we can actually see what's going on here. On the right side here is this thing that says application, POSIX compatible. I'll scroll down. On the bottom, it says Linux specific application. This blue box, this blue, I don't know what this shape is, this blue thing, this blue shape, this is the code that you have written. Comp 2160, you write int main voids, int main int argc, char star star argv. In Java, you're writing public static void main string args. In Python, well, in Python, you just start writing code. This is that code. These big blue boxes here on the right side, this is your program. I'm going to be talking about C specifically now, because this is technically true of Java and Python, but it's obscured a little bit by the fact that they're not compiled languages in the same way that C is. When you write code in C, you use functions like printf. Everybody remembers printf? Thumbs up, please. Yes? I don't care if you don't remember it. Just put your thumbs up anyway. Printf is a function that you call in a C program to produce output on standard output. So text shows up on your screen in your terminal. Printf is not a function that you wrote. It's not. I would not want to write printf. That's a terrifying task to give to somebody. Printf is a function call that you make into this green thing here, this kind of semicircle that goes around here. Printf is a function that comes from the standard library, the GNU C library. This is a function that you can call from your program to produce output on the screen. The GNU C library is a really convenient wrapper that has functions like printf that then interact with the operating system. You write programs, and you can actually also directly interact with the operating system using something called a system call. The GNU C library, when you call printf, does a bunch of stuff, and then it makes system calls on your behalf. You can do this. You can make direct system calls to the operating system, and we'll see this. We're going to do this. System calls are the way for us to ask the operating system to do stuff for us. In this red circle here, this is the operating system. And the operating system is made up of a few different parts. We've got an I/O interface. An I/O interface here, this is where the operating system is interacting with things like the screen and the keyboards. It's interacting with things like printers and hard drives. Not hard drives, but stuff like that. We've got this thing called the virtual file system. And this is where the operating system is interacting with things like hard drives and other kinds of storage mechanisms. We've got the memory manager. And this is where When you call something like malloc, so do you remember malloc? Yes, yes, okay. Malloc is where we're doing dynamic memory requests. Please allocate some memory for me so that I can use it. This is actually a C library function that you're calling. When you call malloc, you're not actually directly asking the operating system. We told you a lot of lies in 2160 about what you're doing when you're writing C code. One of those lies was that, hey, malloc is asking the operating system to give you some more memory. It's not. It really isn't. We'll see this much later in the course, but when you call malloc, the C library is actually making system calls on your behalf to the Linux memory manager to ask for more memory when it's necessary. There's this IPC manager. We've got many different programs that are running that may need to talk to each other. The IPC manager here is responsible for facilitating that communication between processes. We've got the network interface. We've got the process scheduler. The process scheduler here is taking running programs and making sure that they can all access the resources that's exposed by the system fairly. Everybody gets a chance to use the CPU. Everybody gets enough memory that they need. Everybody is able to access the hard drive. The one thing that we're not going to talk about in this course is the network interface. We're not talking about networks here. If you want to learn networks, take the networks course. If you want to do socket programming and stuff, take 3010 either in the second half of the summer or some other time. If you want to do socket programming, you'll do it there. The big idea, though, is that an operating system here is this thing that's managing resources, where resources are things like scheduling. How much access to the CPU does a process get? Memory. How much memory can a process have? The file system. How does something actually access other parts of permanent storage? How can processes communicate with one another? Our operating system is managing resources on our behalf. I'm going to connect to Aviary, and I want to start by launching some processes. It's been a while since you have written any C code, and it's been a while since you've connected to Aviary, so I'm going to just do it. I'm going to demonstrate it. I am not always going to connect to Aviary in class. I've got Linux on my machine. I don't really see the point in connecting to a different Linux machine to do the same thing. But for the purposes of this course, Aviary is this, it's kind of the same as in 2160. This is the homogeneous environment that everything that you write has to run on. Something that may have changed, I don't remember when this came into effect, is that if you're off campus, you have to connect to the VPN. Have you all done that before? Yes? Is anybody not connected to the VPN? No? You have to get the VPN set up to work at home. When you're on campus, you don't need to connect to the VPN. If you need instructions on setting up the VPN, just send me an email. I'll send you something back. Okay. So connecting to Aviary. So I'm going to start up another shell here. I'm going to make that a lot bigger, I think. Yes? You see that at the back? No. Somebody shout at me when you can see it at the really back. That's good? You're okay? Good, good. Okay, thank you. Okay, so connecting to Aviary. If you're on a Mac, if you are on a Windows machine, or if you are on Linux, these instructions are almost all the same. Open up your terminal and start typing. Connecting to Aviary is SSH, and then your UMnet ID. So it used to be whatever. Now it's your part of your last name, and sometimes your first initial, and sometimes a number. Mine is fbristow at aviary.cs.umanitoba.ca. You'll type in your password. There's no prompt here. It doesn't show you characters that you're typing in. This is just type it in blindly and hope for the best. And then you should get a shell. Aviary is upstairs. It's that way. It's a Linux lab. It's got 24 machines in it. All of them have bird names. So Finch is one of them. There's osprey, there's robin, and an aviary is a birdhouse. Ha 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 ha, yeah, it's a good joke. Ha ha, okay. Connecting to Aviary works like this. When you're on campus, you don't need to connect to the VPN. You can just do this. When you're off campus, you do need to connect to the VPN before you're able to connect to it. The accounts have been created as of about an hour ago. Your accounts should be re-enabled at this point. You're welcome to try logging into Aviary right now if you have a machine in front of you. If you had a password before, your password is whatever your password was before. If you didn't have a password before, your password is your student number. If you had a password before and you forget what it is, try your student number. If you can't log in, then I will send you some contact information for the people that you need to contact to change your password. This is your to-do for today, is figure out if you can log into Aviary, because this is how you will submit assignments. If you can't log into Aviary, you can't submit an assignment. So please make sure that you can accomplish that. Okay, so let's start talking about processes. We've got two big ideas right now. We have the idea of something as a program, and we're introducing this idea of something as a process. There's a distinction between these two ideas, and I want to make sure that we're always using the same terminology together. A program is an inert piece of code that's just sitting on disk. It's not doing anything, it's just there. It's just sitting there. A process is code that's currently running. It's a program that is in a state of execution. Something is happening with it. The process, the program that you connect to when you're connected to Aviary, this thing that has printed out fbristow at Finch and then a tilde, this is called our shell. The shell is, it's a program. This is called the TC shell. TCSH. This is a program that's written in C that is currently waiting for me to type something in. And then its job is to start running the programs that I've asked it to run. I'm going to run a program that's called cat. Cat is a program that it concatenates files. That's what its job is to concatenate files. It's called cat because in 1970 whatever, when Unix was first made, disk space was small and having very short program names was important. And things haven't changed in 50 years. Why would we want to write out concatenate when we could write cat? Nobody is, everybody's, I don't know, I'm imagining a picture of a cat right now. I don't know. My cat specifically, his name is Walter. Cat is a program that takes input and it concatenates it with standard output by default. So if I start writing stuff, hello comp 3430 and press enter, it just prints it back out. It just prints it back out. So it's reading standard inputs and it's writing it back out to standard output. My cat's name, I cannot spell for the life of me today, is Walter. Hello, Walter. My cat often bites me. It hurts. He tried to bite me when I was leaving home this morning. He's not a very nice cat. It is dutifully waiting here. This is a program that has a loop in it. It's a while loop, and it's just constantly reading. It's asking, give me input, and I will print it back out for you. Cat is a process right now. I'm going to open up another connection to Finch. So I am using, just so you know what this is, I am using something that's called a terminal multiplexer. This is called TMUX. This just makes it so that I can have multiple shells open in the same physical terminal window. I've used this. This is my approach to computing. You don't have to do any of this. This just makes it easier for me to work. I am, however, going to connect specifically to Finch this time instead of to Aviary. Aviary is a birdhouse. All of the machines on it are birds. And Aviary is what's called a round-robin DNS resolver. Yes, good. It's a round-robin DNS resolver. So you kind of just go to different machines every time you try to connect to it. You can, however, connect directly to the same physical machine by typing in its name .cs.umanitoba.ca. So I'm connecting directly to Finch because I was originally connected to Finch. This demonstration requires that we be connected to the same physical machine. So I'm connecting to the same physical machine again. There's some scare quotes here asking if we're sure that this is the right thing that we want to do. When you do this, it is OK to say yes here. When you're connecting to the same physical machine, make sure that you're checking. This is trying to help you make sure that you're connecting to the thing that you're hoping to connect to. But this is kind of just saying, hey, Aviary has the same key as what Finch is, so make sure that you're going to the right place. I'm going to run another program here called PS. PS is a process listing program, and this tells us what processes are currently running on this system. By default, PS tells us just the list of processes that are running in this shell. I am running several programs. I have several processes on Finch right now. I have a shell. So at the top there, shell is sitting and waiting. My shell has launched cat as a process. That's 2 processes that are running on that right now. I've connected to Finch again. And when I connect to Finch, I get a shell here. And when I ask the shell to run this program, PS, it created a new process for that program. But this is only showing within the context of this shell. So here's TCSH. That's the shell that's open on this side. Here's PS. That's what I asked it to start. PS is finished running at this point, and now it's just the shell sitting here again. I'm going to ask PS to tell me a little bit more about the processes that I am running on Aviary right now. So I'm going to run PS, and then I'm going to give it an arcane-looking set of options, A, and then F, and then U, and then X. You can read the manual page for PS if you want to know what all of these are. But I'm going to hit Enter, and I'm going to get lots of output here. I'm going to zoom in my window here. And what I am looking for is what I am running on this system. So I'm going to do something here that is also a little different. I'm going to pipe the output. So use this vertical bar. I'm going to pipe the output of PS to another program that's called grep. Grep is a program where it is allowing you to give it a pattern, and it's filtering lines. So cat is a program that just sits there and waits for you to type stuff in, and then it just prints it back out. Grep is a program that will wait for you to sit and type stuff in, but it will only print things back out if they match a certain pattern. We can use grep to filter output from something, and so I'm going to filter on cat. I want it to print out only lines that have the word cat appearing in them somewhere. Here we can see that cat is running. There's a couple of other things that have cat, like the grep command has also got the string cat in it. There's other things here that we don't really care about right now. The important one is this one right here. This is cat. It's running as a process. This first column of output here, this is my username. Your username will be something different. This is what's called the process ID. Every process that's running gets a unique number from the operating system. This is your process ID. We're going to use that a lot for interacting between processes. This is grep. It's a running process, and it's waiting around for us to type something in right now. Grep, this is cat, and it's waiting around for us to type something in right now. I want to terminate this version of this instance of cat. So I want to tell it to stop. The way that we terminate an instance of cat is to use that end of file. Do you remember that? End of file, Control D. Control D. So I'm going to hit Control D on my keyboard. That tells cat that there is no more input for it to read, and it should stop looping. I'm going to run PS in my other shell here again, and I'm going to grep on cat. And I'm going to put a couple of lines here just to make sure that we can see it. And now that cat, that first one, is gone. There is no more process running that's called cat anymore. So that used to be up there. It's no longer here anymore. Just this grep and those other things that we don't really care about right now are still running. This is me running processes on Aviary. So what is cat? Cat is a program. It lives under bin cat. So on Linux and Unix, for Windows users specifically, paths are like forward slashes. The first forward slash that we have here is called the root directory. This one here, this is the root directory. In the root directory, there's a folder that's called bin, and then in the bin folder, there's a file that's called cat. Cat is a file. I'm going to run a command here called file. File is a program that tells you about what a file is. So I'm going to run file bin cat. It is something that is an ELF 64-bit LSB Pi executable, x86 64. There's a lot of garbage here. There's a lot of stuff here. It's a file. It's an ELF file. ELF is a file format for programs. When you compile a program, it's in something called the ELF format. If I copy bin cat to my directory, and I call it Walter instead of bin cat, I can run Walter in my current directory, /, and it's running. I'm going to do this on the other side here, PSAFUX, and I'm going to grep for cat. I'm going to run zoom on here, and there's no cat. There's no cat, but Walter is cat. Walter is cat. Ha ha ha. Okay. Walter is cat. Okay. Walter is cat. If I interact with it, Walter is not a very nice cat. It behaves the same way. It's a process that's running that has the same code as what's in bin cat. I can end it with Control D. Let's step back to my slides here. I've got two processes that we're running. Here, let me start those up again. Cat, Walter. I've got two processes running on Aviary right now. What do these processes share? What's happening when we press enter on our keyboards? Let's try and answer this first question. What do these processes share? I'm going to give you 30 seconds just to think about that. What is similar? What's related between these two processes that we've launched? I'm not even going to ask for any feedback right now. I'm just going to give you a chance to think about this. Okay, so what do these resources share? What do these processes share? They physically share the same physical processor. They share it. We're going to see a lot later how this is working. We're going to pretend that it's not a multi-core CPU. We're going to pretend that. We're just going to pretend that it's a single-core CPU. They share the same physical processor. They definitely share the same physical RAM. They share the same physical hard drive. I believe there are SSDs on these machines, but they share the same physical permanent storage mechanism. They also share the same code. they're literally the same file. They're completely the same file. In 2140, you did caching. You did hash tables. You kind of calculated the hash of something. SHA-1-sum. This is a hashing algorithm. This is a cryptographically secure hashing algorithm, but it's basically you give it input and it produces a number that represents what that input was. It's the same general idea as hashing. SHA-1-sum of bin cat and SHA-1-sum of Walter are identical. They are the same file contents. They're not the same physical file, but they're identical in terms of contents. For our purposes, outside of physical resources that these two processes share, the only thing that's common between them is the code. That's it. There's no other relationship between these two things. They don't share anything else. They can't read each other's memory. They can't know about the fact that they share the same CPU, but they do share the same CPU, really just the same file. The next part of this is what happens when we press enter on our keyboards. Our textbook describes this process. It goes through the exercise of describing this process. It goes through the exercise of describing this from the perspective of what you were doing in Comp 2280 with, again, system versus user mode. So going back and forth between those two things. But it kind of leaves the implementation as an exercise. Shows you some code, but to see it running is something different than to read it on the page. We want to answer two questions. The first question is, what is our shell doing? So again, we've got TCSH on Aviary. This is a program that has been written that's just sitting there and waiting for us to type input, and then it does something for us to ask the OS to run things for us. And then what's the operating system doing? So what is the OS itself actually doing when a request has been received to start a program up from the disk? We're going to answer the first question first. What's the shell doing? The shell is asking the operating system to do something. The shell is not a part of the operating system. TCSH is not part of the operating system. On my machine, I use a shell that's called fish. That's not part of the operating system. On your machines, if you're running Mac OS, you're running Z shell or Z shell. That's not part of the OS. That's a program that's installed along with an operating system, but it's not part of the OS. If you're running Windows Subsystem for Linux, you've got bash. That's just a program. All of these things are politely asking the operating system, this core thing, to do stuff using an API. The API that they're using is this idea of system calls. The API that this program, our shell, is using is 3 specific system calls. They create a new process by duplicating the shell's process using something called fork. They replace that new process's code using something called exec or execvp. These look like function calls because they kind of are function calls. And then waiting for that process to end by calling another system call called wait. Let's do this. Let's start writing some of this in to get a sense of what this looks like and to get a sense of how things are working as we're stepping through it. And I'm just looking at the time, and I think that we're going to be having to finish this up next class. It's totally OK. Let's start typing this out, get a sense of how it works, and then, yeah, let's start typing this out. Like I said, I'm going to do this on Aviary today, but I will often just do it on my own machine. Whether it's on Aviary or on my own machine, I'm probably going to be using VI to do C editing. I probably won't. I don't know. If you want to learn, do you want to learn VI? Do you? OK. I'll try and verbalize what I'm pressing on the keyboard, because sometimes it's just like muscle memory that I'm typing stuff in. But yeah, I'm going to do this all on Aviary. I'm going to always do it in the terminal when I'm doing code examples. Okay, so let's get started here. So I am going to start by making a new file called hello.c. Hello.c is, I don't know, it's a good example name for a program, and I'm just going to start typing in my C program. Once you enter VI, you are in normal mode. Normal mode is just like you can navigate around the file, but you can't start typing anything yet. You have to enter insert mode before you can start actually typing stuff in. There are several ways to enter insert mode. I am going to enter insert mode by pressing I on my keyboard. If you want to learn Vim, get a cheat sheet. Like seriously, actually print it out and like carry it around with you so that you can just look at it quickly. It's better than just having a cheat sheet open in a tab in your browser because you can physically look at the cheat sheet. If you need a printer, I'll print it for you. Just send me an email and I'll print it. I'm going to start typing in my program. I'm going to say number include stdio.h. I'm going to use the standard library for some parts of this, but I'm also going to be using system calls to do stuff directly, so I'm not necessarily going to be working through the standard library, but for now I'm just going to include it. I'm going to say int main, and I'm going to accept no arguments in my main program, so I'm just going to say void here. Having voids in between parentheses is different from having nothing in between parentheses in C. Nothing in between parentheses means accept any number of arguments. Void means specifically don't accept any arguments. I prefer to do this when I'm not accepting input on the command line as arguments, so I just put void here. The first system call that we're going to take a look at is the fork system call. I'm going to consult the manual pages on this. To consult the manual pages, the command is called man. The second argument that I'm typing here is the section number that I want to use. There are several different sections of the manual pages because there's often like a program that has the same name as a function that has the same name as a system call. It's telling the manual program which section you want to refer to is sometimes required. You have to just tell it specifically. So I want to do the system call for fork, and that's usually 2. This tells me what I need to include. There it is right there at the top. So I'm going to add that immediately. Say number include sys types.h. And I'm just going to blindly copy this right now, unistd.h. And what this is telling me is that I can call fork. It does not take any arguments. It has void here, so I don't pass anything to it. And what I get back from it is a PID-T. So PID-T is the process ID underscore type. PID is process ID. So I'm going to say PID-T child. And then what I'm going to say after this is child is equal to fork. And then I'm going to say return exit success. And this comes from stdlib.h, so I'm going to add that. So exit success is a constant that comes from stdlib, so I just added that. And then I'm going to save this file. So I'm going to exit insert mode in Vim, hit escape. And then to save, you hit colon and then W to write. This writes this file out. And then I'm going to quit my manual page here. And I've got in here hello.c. I'm going to just say make hello. I don't want to make a makefile right now, but make knows how to build C programs. So I can just say make the name of the file .c, and it will compile it for me. If I run this program, hello, nothing happens. OK, that was exciting. That was really exciting. What fork does is it takes a process and it duplicates the process. I'm going to add one line to this. And the line that I want to add to this is after the fork has been called, okay? So I'm very intentionally writing this after the fork function call has been made. I'm going to say printf, my process ID is, I'm going to put %d, format code, new line. Is that legible at the back with this theme? You can change it to a light mode instead if that helps, but if it's legible, it's okay. Okay. And I'm going to put child here. I'm going to escape, :W. I'm going to make hello again. And I'm going to run it one more time. And I want you to predict the output here. I'm telling you verbally, the fork system call duplicates a process. My question is, how many lines of output are there going to be? There are two options here, 1 and 2. How many lines is this going to print? I will wait until everyone has put up 1 or 2. Everyone has to put up 1 or 2. Even if you're just guessing. I'm not putting you on the spot here. This is not the final exam. Okay, okay. That's close enough to everyone. Okay, we get 2. We get 2 lines of output. I'm going to add another thing here that says char input. And I'm going to say input is equal to get char. So get char is kind of like fgetS or fgetC or whatever. It's just getting input from standard input, a single character from standard input. The reason that I'm putting this here is that this blocks. I'm using this specific word. It's blocking. Get char will cause this program to stop running until input has been given to it. So it will not proceed past this line until I actually type something in. Blocks is a word that I'm going to use a lot when we're talking about threads and processes. So blocks means it just stops and it waits until some event has happened. I'm going to exit insert mode, write it, I'm going to make it, and I'm going to run hello again. Okay, so now it's stopped. It's just sitting here and it's waiting. There are two lines of output here, and we've stopped and we're waiting. I'm going to connect to Finch again specifically, and I'm going to run PS. And I'm going to say PS A, because I don't want to see all of that output, so just A this time. And what I get from PS is 2 processes. One that's called hello, that has process ID 110523, and another one that's called hello, and it has process ID 110524. And that's the same as this. The other one, though, it says my process ID is 0. That doesn't really make a lot of sense. That doesn't really make a lot of sense. When we call fork, we have 2 branches coming out of this. We have 2 different processes that are starting to execute after that line. I'm going to do this one more time, but here I'm going to say input is equal to get char, blocks. I'm going to hit Control-C on my keyboard to terminate those processes. I want them to stop. I'm going to run PSA here to make sure that there is no hello running anymore. There is not. That's good. I'm going to make hello again, and I'm going to run hello. And right now, we have a single hello running. It's currently blocked right here. So it's stuck on that first line, waiting for us to type something in. It is blocked. It's waiting for an event, and the event is something is entered. I'm going to hit enter on my keyboard, and then it proceeds. It's allowed to continue. And now we have 2 processes running. We've duplicated this process. There are two different processes that are running now. One of them has a value in child that is 110569. The other one has a value in child that is 0. I'm going to quickly wrap this up. After we fork, I'm going to delete this other line of input here. After we fork, the way that we figure out if we are in one process or the other, and we have this terminology of parent and child process. The parent process is the one that was running when it first blocked, so before we hit the fork line. The parent and child are both running after fork has been called. The way that we know about which of those two that we are is to ask what the return value from fork was. So I'm going to say if child is equal to 0, this means that I'm in the child branch. This is the child process. And the other option here is if it's non-zero. So if it's something that is non-zero, so else in the parent process. And I'm going to say in here, printf child ID is, and then %d. And I'm going to comment this line out. I'm actually just going to delete this line because it doesn't actually make sense anymore. I'm going to delete this line. And I'm going to hit Control-C. I want to terminate these processes. I'm going to make them again. I'm going to run it. It's blocked. It's waiting for me to hit Enter. So right now, we are on this line in one single process. I'm going to hit Enter. And now we had two processes running. They both immediately exited. The difference between these two processes is that after the fork system call was made, each process had a different value in child. One of them had 0. That's the one that was duplicated for the one that we have right now. The other one has a value in it, which is the child's process ID. So both of these processes are then running through the same conditional block and the same rest of the code, but they each take different paths through that. One follows the first condition of the if branch. The other one goes to else because the value of that variable is different between the two processes that are running. OK, I have taken up too much of your time already. What I'm going to say here is that we're going to finish this tomorrow. We're going to finish this tomorrow. My goal with today and tomorrow is to get you into shape to do the lab. We're going to circle back and talk more about the theory that's underpinning this after that. So we're going to talk about what the operating system is doing internally after we finish the mechanical. Here's how these APIs work. Thank you all for coming out, and I will see you tomorrow. Bye, everyone.